You see the plot. We can go ahead and interpret this, but this is not the one that we really want. We want the one that gives us the coherence. So we can just forget about this one and look at the next one. So what is the next one? We have WP. This will give us the same thing. Okay, I'm going to, so watch here. Color.key equal to I. And here we have which image equal to WP. So if you come down here, I've given you different things. Select WC, coherence, select WP, power, select WT, transform. So here, this is basically the same as the one we have plotted. I'm giving you the different things in case you want to try out. Realize this is the same, right? Exactly the same as the previous one. And if you follow, you see that when you read papers, nobody presents this. Have you seen the papers? They never present this one because the literature, we don't need this for the purposes of our study. The one we need is the coherence. I've written here our choice. So which image WC wavelet coherence? That's the one we want. So I can, okay. So let's see how it goes. Perfect. See that this is a bit different. Okay, so let's make it big. See if it will be better. So I would suggest from scale 2 to 16, you write a blanket statement for that, except that you may have to take note of this part. In 2020, early 2020, scale about 6 to 16, I don't think you can ignore this. General pattern here in the whole of this data, you see the pattern. Yeah, so it is the actual out of phase and X is leading, so the market is leading. If we are not sure, we can go and check. It's out of phase and X is leading. No, actually it's Y that's leading. Okay, so we are here. True. So it is out of phase. It means that the exchange rate and the stock market are moving in the opposite direction, and the exchange rate is leading the stock market. So that's one. Okay, so here between scale 6 and 16, we realize that the market, they are out of phase, and the Y is leading, which is the exchange rate. Okay. Then we go to, we can look at so we can look at this one. This is basically the same thing. Out of phase, exchange rate is leading. Okay. So see, this is similar to, so you realize that the whole of this area is similar. So you see that now X is leading and then Y is lagging, but they're out of phase. The stock market is leading and the exchange rate is lagging in the long term between about 128 scale and the 256 scale. From about 2015 all the way to 2021. So compositely, you have to make a choice. Let's look at the last one at the top. The very top there is out of phase and what is leading and Y is leading. So that would be the ZA. So with this, and when you start writing and you start reading your work, you're reading other works and interpreting, it will become even more clear. Okay, so let's choose different pairs. Another pair and see.
Okay, we can do the S&P 500. The
S&P 500.
Nigeria.
Nigeria. Which one is Nigeria? NGN.df or?
No, it's written Nigeria in full.
The Nigeria.df. You can see it. Okay, let's try that one. Okay, the composition is done. You can just look at this briefly, but that's not what you are interested in. You don't need this one. Also don't need this one. What we need is our coherence plot, which is here. So let me change the names. This is SP 500 and Niger. Okay, that's fine. This is interesting. So the relationship between the Nigerian market and the SP variant is really scarce. Like it almost never exists. Very sparse. Okay. The only part that we can really talk about is these small patches. So this is, let's see. Let me use my annotate. Let me do this. Yes, okay. Green is fine. So you got this one here. No, I think green is the wrong color because we are blue should do. So here and here, trace to just like 64 and just a little above it, so like here. So they are in phase and Nigeria is leading. They're in phase and Nigeria is leading, and that is just on the fringes of the long term. I mean, medium term. We are just getting out of the medium term between 20 what? Maybe after the first quarter of 2020 all the way to about middle of 2021. Okay. Then the other thing that we can talk about is this one here and here. So here, this is actually fourth quadrant, right? So between 2015 and about middle of 2017, the Nigerian stock market and the S&P 500 are moving in the opposite directions, and Nigeria is leading. Oh, let me see.
X S&P 500.
X is leading. Okay, that makes sense. S&P 500 is rather leading in the long term. Okay. See, so you see how the relationships differ. Any other pair that these are the data. How about BRVM? Let's look at something about BRVM. Oh. Yes, see that here with what?
I don't know if it's.
You can check with the S&P or you can check with the here. Let's transform. Do you see the mistake that I've done? I repeated the DFs here. Yes, and now it should work now. So you see, maybe your variables are, you don't have to really pay every one of them. You can selective. So okay, transformation is done. Then let's go to our coherence. It was S&P 500, no, FTSC, FTSC, and S&P 500. Okay, first of all, do you see some of the coherences that are insignificant outside of the cone of influence? So those ones, you ignore them because they are not significant. Okay, so I see a lot of in phase, a lot of movement in the same direction. Okay, so we can cut out all the way from scale 2 to 16 and write one blanket description for them. A mixture of fast coherences, both in phase and out of phase, in the short term. Yeah, in the short term, about scale 2 to 16. For daily data, 2 to 16 is enough to be a short term. So less than a month. Okay. Then we can start looking at the concentrated scales. Okay, so let's start from here. 2020 will always give us some highlights. Okay, so look at this one. Let me add this one like this. So in phase, I see, so this part, for example, when you do multivariate, you realize that you divorce bivariate. Anyway, so this one I think is more of Y leading. Y is the S&P 500. Yeah, for this one. How about this? Here, I think Y is still leading. Yeah. Y is still leading. So S&P 500 is leading the FTSE. Okay, so very early 2020, beginning of the medium term. Okay, from about, so here is, we are still in the short term here. Okay, so this is a little bit of the short term, but we go here in the medium term. Okay, so FTSE is still leading, but when we come here, we can still look at that as deep in the medium term between the end of 2019 and up to the, let's say, maybe the third quarter of 2020. We see that there's a measure of leading here. So if you divide it into two, realize that. So here we realize that the FTSE is lagging S&P 500. Here, S&P 500 is leading the FTSE. Okay, so it's a tight contest, if you like. When we come here, it's clear that the FTSE is leading the S&P 500 in phase. When you come here, it switches. The FTSE is now lagging the S&P 500. But here in the long term, I do not see a phase difference. That's what I see. Okay. So a lot of activity is from the medium term going around 2020 to 2021. And then in the long term, we have between the end of 2013 and about the end of the whole of 2015. Yeah. So you can just leave it blank that there's no compositely leading or lagging variable. So this is how we do it. Okay, so the data is prof. Okay, so let's look at it. We try some decompositions.
Yeah.
Okay, so CP2. So let me see. Let me decompose PR and C. Let me attach first. So PR. The same thing, is not dyadic. You can change, can just specify the filter, nothing changes. But we can make it non-dyadic. To forget about the fact that it's to be discrete, then it will transform for us. Bam. Your data is 200 points, right?
Yes.
And you see, because of we have a lot of zeros, keeps cutting the data down. Okay, so we have 1 scale, 2 scales, 3 scales, 4 scales, and then the scaling factor. Okay, discrete. We don't need that one, but yeah, you just want to see how it looks like. How about what are your variables again? How about CR? I just have to put it here. Forgotten. So CR. Yeah. Wait, non-dyadic. So there's something really wrong with CR. Even after we have specified that it's non-dyadic, it's still giving us that. Okay, so that one transforms. CIR and C. That also transforms. And then let's look at the last one. The last one is what? RY. That is what variable is that?
Real GDP.
Real GDP, okay. That also transforms. That's good. Okay. So now let's go to the more or less transform. What we did was discrete, more or less. So is it a monthly data?
Quarterly.
Quarterly.
Yes.
So, okay. So we have 1 data per quarter points. Over the year, we have how many data points? Quarter?
Four a year.
Okay. Okay. We said we're going to detrend. So let me check briefly. Let come. So lowest dot span parameter alpha in lowest controlling the degree of time series smooth if the time series are to be detrended. No detrending if lowest equal to 0. Default is 0.75. Okay, so we can put 0.75, or if you remove it, it will detrend. So let's for your series, we said we want to detrend, so let's put 0.75 there. Okay, so we are choosing, let's choose one. PR is the first one.
Yeah.
We are choosing this as PR. Done. Your data is not long, so you see how quick it was. Okay. Again, here, you won't see a lot of it. We just have to go into the Excel file and look at it. So let's write it to Excel and we'll go and see it. So you see what I've done. Once I use the same CMW.RI, is going to override the previous one. So what is in there will be the current one we just did. Where is it? Yeah. As for the partial cost, I'll explain to you. So Providence, you see your decompositions. We have the real parts and the imaginary parts. And they will come with their power levels, their averages, their phases, the phase differences, all of that for each one of the amplitude also, forgot to mention. That's why the file is really big. Okay, great. So we can try another one, let's say the CR, and see with default resolutions. The CR data is a problem. So the decompositions are bringing NAs. So you may have to look at that data again. If it's possible that you remove it or apply maybe some constant values to those places, and they will not actually affect the results. You can do that. I don't know whether it's about the zeros or constant values. Let me look at the CR briefly. Let's look at the CR value. Yes. No, there's something wrong with the data. Let's move on. Let's check another variable and see another variable. Okay, so that decomposes. You can go and look at it in the file. So let me try the RY. Okay, that's also does. Good. So all these ones are the same things, trying different variables. Okay, yeah, so we can leave that one. Now let's do univariate analysis. We want to see where there was a lot of activity, volatility, oscillations, and we can trace it back to what happened in the market. Okay. So our data frame is CP2. So we are now here going to choose which variable we want to work with. And the PR works, so we can try with PR with default resolutions. So we say we are going to detrend with 0.75. Yeah. Yes, so we have changed that. So we analyze, we decompose, and then we can see the plot. Let me change this to CPI inflation, CPI. So this one is up to you. You can give it any proper name that you want. So let's plot it out. So it gave you 1, 2, 3, 4, 5, 6 scales for quarterly data. So 64 quarters is how long? 16 years.
Yeah.
That's a long time. Okay. So what we are looking here is where there's a lot of activity there. You see the red, that's very high volatility. Yeah. And this is the middle of what? the middle of, that's okay, it's quarterly data. So if this is between 2010 and 2020, that's 10.
2020.
So that's around what? Remember, you cannot talk about this one. The one that is beyond the gray, that's insignificant. So it's out of the cone of influence. So we can only talk about this part. So, and this is the hottest part where there was a lot of volatility. And that's around 2015. And 2015, 16, thereabout. What happened in the market for 2015 and 16?
I could talk about the exchange rate. We had a lot of volatility. Maybe we can confirm it when we show the exchange rate.
So let's choose a long term that you want, because 64 is too long, in my opinion. So let's look at this here. It's PR, right? So how long do you think you want your long term to be?
5 years.
So that would be how many months?
That should be like 1 year is 4 quarters. So 5 years should be like 20 quarters.
So it's in powers of 2. So let's see. 2 cube is 8. 2 of 16. So I think we can do 32. So let's now do this one and see. Okay, now let's show the image. See, a lot of the volatility is insignificant, out of the cone of influence. So you see how your scale will affect your analysis. So let's try another variable and see what variable do you think you want to try. You can try with the 6 skills, and you can try with the 32 skills.
Exchange
rate. That's the one, that's the ER, incorrect number of dimensions. Oh, that's not what I should have changed. ER. Okay, so you remember you mentioned exchange rate volatility. That's showing more. And it's around the same period that you mentioned, both. So it goes short term all the way to the long term. Okay, so this we'll show the plot shortly, and then you will see. Let's see if you choose 32 skills, how it will look like. Okay, let's look at the plot. This also doesn't. So you have to decide, maybe you may have to get a motivation for the 64 and use that. Or if you have a strong motivation for the 32, then it will show you how the data looks like. Now let's do this one. This specifically this one here, 32. So we are not setting. Let me detrend 7.5. We are not setting any resolutions. No DT, no DJ, no 1/DJ, and all of that. We're just using the original data. So it's CP2. I suspect this will give us something interesting. And then ER. You see, this is better. Yeah, this is the exchange rate.
Okay.
But here, we didn't specify any resolutions apart from the fact that we detrended. So we didn't set any default, but we set the lower to be 2, the upper to be 32. Let me remove the detrending and see what happens, just briefly. You see, when we
to the outside,
it goes away. I think it's okay to detrend. So you have your deal now. Then this should help. Okay, so now let's see the reconstruction and then the plots of the series. So it is wv.gd here. So you see where you have your volatility is still showing here, and this one will look really nice because the data is not smooth. But let's see. This is very quiet all the way until the year 2000. just as the data is showing. Anyway, so now let's move to the bivariate. CR is the one that's giving us trouble, so we can hold on with it now. So this is the thing, my pair. The pair is the two that you are going to choose. Yeah, we can start with the first two. Let me just add CR and see if this time it will behave. Just for the purposes of argument, let's detrend with 0.75. So realize now we are all able to pick out the errors. It's decomposing. Let's see the plot and see. Okay. So we agreed on what? The 32 and 2. So let me put them back. Okay. So let's get CPI against. So let's see how the plot looks like. It might be the same. But again, we don't need this one. We are interested in the coherence. So forget about this plot. You will usually not see it in the literature, which is the same as this. Which is the same as this. But what we are interested in is the coherence. That's the one that we can interpret as correlation, but this time in time and frequency domain. So this is the one we are going to interpret. Okay, so which image we see as the coherence? Wow. What are the two variables again?
This is inflation and credit.
So a lot of short-term coherence all the way until the year 2000, or getting to the end of 2000 in the short term. Remember our definition of, would you suggest contagion between, the beginning, is it 1970 all the way to?
1970, 71 to 2020.
Yes, not quite 2020, but that's like, let's take that as say 2009. Here. Let me take. Yeah. A lot of.
I see them to be out of phase.
Yes. So out of phase can also be contagion. They don't have to be in phase. Yeah. So this is the short term. This is like if this is 2 and that will be 3. So 3 months. Okay. So
it's a quarterly data.
Quarterly data. So that's a year and a half.
3 quarters is even less than a year. So this is like 9 months.
Yeah. It's not
3 quarters would be like 9 months. 4 quarters is a year.
Yeah. So high levels of coherence at what? High frequency.
Yeah.
One of the definitions. Okay. So what do we think? They are out of phase generally. So they are in the 3rd quadrant. Is that right?
Which period are you referring to, Doc?
The one that I highlighted here.
Okay. Yeah. That should be the third quadrant.
They are moving in the opposite direction, and I think X is leading. So here X is the CPI inflation. So where is it? Let me just look at it. out of phase, and X is leading. So X is CPI. So CPI is leading the credit for that period. Okay. When we come here, wow, that's a long stretch of coherence. Come here, all the way. Remember, don't anything beyond the gray is insignificant.
Okay.
So what do we see? Is it? So I do not see a lot of phase difference here, but I can see phase difference here, which is still CPI leading, but out of phase. So in the medium to long term, early 1970 all the way to like 75, thereabout. Yeah.
Yeah.
And here. Okay, so we know that one. Then we cannot ignore these ones. I think they are important. These three, we have to talk about them. And we have to talk about this one also. Talk about this. Talk about that one. And lastly, talk about this. Okay, so in the long term, again, CPI is leading, but they are out of phase. Now, when we come here, for example, CPI is leading and they are in phase. Okay, so they move in the same direction, but CPI is leading. That's like 2012, thereabout. 2012, there was what? Was elections or something like that?
Yeah.
So CPI is leading and credit is lagging. When we come here, there's a little switch. Realize that they are in phase, but now credit is leading instead of CPI. That's the same thing here. Credit is leading instead of CPI between the years about 20, so maybe 2009 and 2009 where. Okay, so here as credit is leading and they are in phase. You go here, there's a mixture. Out of phase, CPI is leading. In phase, CPI is leading. In phase, credit is leading. So you are now have to decide compositively which one is leading. I think it's CPI.
Inflation.
Yeah, inflation. And it has even shown contagion. So if CPI is leading and contagion, that means the driver of the contagion is CPI, not credit. And we can know which period that's happening and which time horizon. Okay. I choose another 2 pairs. And then
let's try nominal interest rate and exchange rate.
Nominal interest rate and exchange rate. What pair is that?
ER and IR.
Okay, let's look at how that one works. Not very strong relationship. So the one that we can really talk about is between the 8th scale and about the 20th scale, between about 2015 and 1995 and about 2002, where they are in phase, and I think IR is leading. Yeah. This is the one I just explained. So I think IR is leading. They are in phase in the medium to long term for between about 1995 and early 2002. That's the first one. And then we can talk about this one. 2010 and between 2010 and 2015, they are in phase and IR is leading. So obviously IR is compositely leading. I cannot infer contagion. And so that's the long term. In the short term, there's just sparsity of relationship and a mixture of in-phase and out-of-phase coherences, all the way to scale, all the way here, about scale 10. Nothing really is happening there, except from above. Look at this part here. This blue and green, best yellow means weak coherences. See, so blue is 0 all the way to about 0.7. They are not really strong, and you see here. So between 1972 all the way to 1990, the relationship between exchange rate and IR is quite weak. Now let's do a last pair, and then we can call it tonight. The last
try interest rate and then read GDP.
Okay, interest rate and real GDP. And those are ER and RY, right? IR and RY. Okay, let's decompose. And then let's plot IR and YY. So this one, you can give it your proper names when you are doing your work to make it them descriptive. Okay. This is very similar to the other. Realize that way. Yeah, these were two places where there are a lot of activity here. So in phase, X is leading. X is what? X is what? IR, interest rate. And in the real GDP is lagging. Okay. And this is a little bit weak. So they are out of phase, and what is lagging? And then X is leading. In phase and X is leading. Okay. So here they are in phase, X is leading. They are out of phase, X is leading. So X is the king. You know which period they occurred. So this is like in the medium term, X is leading between about 1988 and about between 1988 and let's say 1995 in the medium term, between the scales of 6 and 10. That's medium term. X is leading. And when you come here, they are out of phase and still X is leading. That's in the long term around where? This is like between 2015 and about 2017. So this is how the analysis go. And remember, when it's leading or lagging in Wavelet, we can infer causality. So you can see the variable leading or lagging as the causal variable. Yeah. So then what we can do is that we can do partial later. We can do a little bit partial. So you have EIR and RY. What if the relation between IR and RY is also influenced by an external variable? Let's say GDP, let's say CPI. If we control that, it's possible that the relationship will change. So that's where partial comes in. So there will be a third variable which is held constant so that the relation between these two will not be affected. So if you have one variable that you think can influence the relation between two variables, you can hold it constant and see the non-tampered with relationship, if you like. So that's wavelet. So that's the partial. My question for you now is, from this plot, you cannot find a relationship between IR and CR. You cannot find a relationship between RY and IR, as well as say PR. You can't. You have to do pairwise, and it's difficult to do that cross or multiple comparison. And that's one of the advantages that you can use with the multiple wavelets, and put all of them together and give you the relationship at once.